Now, okay, fantastic. So good morning, everyone. Welcome to Glass plus Building Information Modeling, BIM. This is the Glass Unlimited event for June 2022. My name is Adeolu Okulaja. I'm the coordinator for the International Year of Glass celebration in Nigeria. I want to say a few words by acknowledging the hard work our LOC has been doing, which is a local organizing committee, and also to thank everybody that has contributed in no small way to the success of our activities so far. I would like to, at this time, bring in our Dr. Bello, who would give a brief history of the Faculty of Environmental Sciences, University of Lagos, so that we can now kick off the event with at least some background information. Thank you and have a wonderful stay here. Over to you, Dr. Bello.
Thank you very much, Architect Adeolu Okulaja. As earlier mentioned, my name is Dr. Bello Wasiu Adeniro, a lecturer in the Department of Quantity Surveying, University of Lagos. A brief history of the Faculty of Environmental Sciences in the University of Lagos. The Faculty of Environmental Sciences actually started program in 1970. And currently, the faculty is having about 5 departments, having grown over the years, with departments of architecture, building, estate management, quantity surveying, and urban and regional planning. All the departments offer academic program and of course research at both undergraduate and postgraduate levels, and enjoy accreditation, full accreditation by both the National University Commission and of course the professional bodies of individual departments of their regulatory bodies. Apart from core specializations, postgraduate courses also include environmental design, urban design and landscape, architecture, construction management, construction technology, and of course, building services, facilities management, urban logistics, transport policy, and of course, quantity surveying. In addition, there is a professional master's degree program in housing management and development. And as we speak, the current dean of the faculty is Professor Mudupe Umiri. Thank you very much.
Thank you so much for that introduction. And I know that we are all on board with the BIM and with the International Year of Glass celebration. I'd like to acknowledge the LOC members at this event. One of them is Dr. Bello. Can all the other LOC members please acknowledge themselves? Hello, we can't hear you, sir. Mr. John, we can't hear you at all. The audio is so bad, we can't hear you, sir. Dr. John Ame, unfortunately, we couldn't hear you. Does anybody in the LOC want to say a few words after?
Yeah, please, let me mention this. Is Professor John Ame.
Oh, sorry about that, Professor Ame.
Is there,
yeah,
is there,
we
is there
couldn't hear you. Okay.
So, Prof, we couldn't hear you. If you can come back online, we couldn't hear what you were saying.
Okay. I think we're sort of running low on time. So I don't know whether Professor Mike Adebamawa is available on the platform to say a few words. If he is, I'm sure he would want to say a few words, but I don't think he's here at the moment. So I think we should just go into the meat of it. Can we have Dr. Bello, can you please introduce the speakers that we have for today? Thank you.
Yeah, like you mentioned, the members of the LOC, like you mentioned, the chairman of the local organizing committee of the International Year of Glass is Professor Mike Adebamawa. And of course, we have the dean of the faculty as the chief host, as the host, anchoring most of our programs. That's Professor Modupe Omiri. And we have architect Adeolu Kulaja, your humble self, and Dr. Ilechuku, Dr. Paul Obi, Dr. David Adio Moses. We have Dr. Funlola Famuyiwa, Dr. Patricia Kukoyi, Dr. Kudrat Ibiola Zakaria. We have architect Andrew Akinubi, and we have Builder Digboyega Shutubo, and of course, Mr. Akib. Those are the members of the LOC. And for our program for this morning, we have our speakers that are going to, handle the presentation session. So the first speaker we shall be having today is Stephanie Adisa, who provides innovative, sustainable, and design-driven building designs and planning expertise for outstanding projects, while having a positive impact on the built environment. Stephanie is a practicing architect who also engages in artistic and academic projects. Since 2015, she is the director and lead architect of the architecture firm Studio Elementals in Lagos, Nigeria. And of course, she works internationally. Recent works have been in Nigeria, Ethiopia, South Sudan, Liberia, Iraq. Apart from leading Studio Elemental, she's on the advisory board of Open House Lagos and engages with urban research stakeholders and partners, such as the Lagos Urban Design Initiative. Stephanie holds a degree in architecture from the University of Applied Arts, Vienna, where she graduated. Her architectural clients include the UNIDO, Frankfurt, Landmark Africa, and of course, Goethe Institute. So it is my pleasure to welcome architect Mrs. Stephanie Adisa to make our presentation for us this morning. Thank you.
Well, good morning, and thank you very much for the introduction, Dr. Bello. Thank you very much also to Mr. Okulaja for inviting me here for this event today. I will be sharing my screen shortly for a presentation, and that will talk about glass, BIM, and also parametric facade design. Okay, one moment, please. All right, are you able to see my screen?
Yes, we can see your screen.
Now we can see.
Stephanie.
Good.
All right, wonderful. So I will be speaking I was speaking in a very applied, context concerning BIM and glass design. I was hoping that the other speaker would give an introduction on the topic first, but I believe most of the listeners already have some kind of background understanding on the matter of building information modeling and how this could affect a possible facade design. So I am the founder of Studio Elementals Architecture, which is an architectural firm based in Lagos, as Dr. Bello has mentioned. We do different kind of building designs, different skills, and also different programs. And building information modeling and parametric design techniques definitely play a large role in coming up with designs for buildings, especially for facade design, and taking into account glass, sun shading, and also climatically smart designs that take into account environment. So I will be speaking about the parametric modeling aspect of BIM and how this can be used to generate glass and facade designs, how to take into account modularity, and how parametric BIM modeling can enhance the efficiency and also flexibility of the design process. And then, of course, applied on an example. So to begin with, parametric modeling is the creation of a digital model based on a series of pre-programmed rules known as parameters. The model or elements of it are generated automatically by internal logic arguments rather than by being manually manipulated. And such rules could possibly be size of facade paneling, shading of a glass facade, or natural sunlight into a space. So I'm using this example of a building design that we are currently working on at Studio Elementals. It's a large-scale industrial mixed-use building, including offices and a hotel. It's a logistic headquarter, which is basically an industrial building, but which needs to be integrated in its surrounding urban environment. You can see the site plan here. It's a large footprint of 8,000 square meters on a 10,000 square meter site. And what this means is that we have thousands of square meters of facade area to design, and hopefully, in the most efficient way. So we are encountered with several challenges here before even starting the design process, which is, first of all, how to disguise an industrial building in a more commercial environment and make it appealing, to the urban environment, so not to affect the area where it is in. Then how to design a large facade area efficiently, and also how to handle transitions between more visible and more articulated facade areas and maybe more industrial reduced areas where the building is less visible. Then, of course, we need to take into account material waste. The building industry accounts for a very, very large amount of waste and also carbon footprint. So every material that is wasted is really a sad business, and therefore we can, as architects, can make sure that we design efficiently to reduce waste during construction, and therefore also save costs and also be more sustainable and climate sensitive, and therefore make the building greener. So I should also say that this project is planned to be EDGE certified. So it is planned as a full-on green building that will receive a certification by the time it is completed. The construction has started already. Now, we usually start our designs with a climate analysis. And I'm sure most of you will agree with me that, especially when we think about glass in facades and facades design in general, we must have a good understanding of the sun angles, the sun radiation, the impact of the environment onto the building, including wind directions and precipitation and temperature of the area. This building is located in Lagos, which means that we have a very strong east-west direction of the sun. So taking this into account, the different facades, the 4 facade areas of the building will have a different kind of sun variation, radiation, and also access to sunlight, natural lighting in the space. So you can see nicely here in this sunlight analysis how the east and west parts of the building have the longest hours of sunlight. And this also enables us to control which spaces should receive more natural lighting, while others may not necessarily need so much access to natural sunlight. We also did the same for annual sun radiation, and this also gives a good understanding of a dense environment. Sorry, my headphone. As to shading of other buildings, for example, and understanding which parts of the facade need to be more shaded than others. To move further with this climate analysis, we also typically look at sun shading possibilities for glass areas. So here we assume the east facade in the morning from 9 to 11 a.m., for example. And we can see that the sun angles change drastically from 0 to 75 degrees. And what this means is that depending on the time, the sun shading slats that we assume here actually need to slant according to the angle of the time in order to provide efficient sun shading. And you can see the effects on the right. The yellow surface shows the direct sunlight. So in this number 1, no shading panels, we can see that we have quite strong direct sunlight into the space. Whereas on number 2, with horizontal shading panels, we can see that the direct sun is slightly reduced, but not yet really efficient. And then number 3, vertical shading panels is already reduced further. And with organically shaped sun shading panels that adapt to the angle of the sun, we have the optimized sun shading capabilities of the facade. Now, of course, to come up with a facade design for such a large structure, we must think of design iterations, because maybe the first design is not the best one. So I want to lead you through several ways or several design tests of this parametric facade modeling to show you the variety and different design approaches that we have gone through to investigate this facade for this building. So we have different design iterations showing different facade angles, different kind of sun shading paneling, maybe a more folded technique, or stripes. Then other kind of stripes with more glass, more solid options. So all these different iterations give us the opportunity to, test the sun shading capability, and also the climatic conditions of the facade in more detail, and to come up with the most effective way of facade design for this building project. We used a Rhino grasshopper as the scripting tool to come up with this parametric design for the facade. And this tool is very powerful and enables us to really design this on a parametric model without having too much effort of redesigning by hand and so on. So you can see here, the final design was made up of vertical facade strips and glass elements, of course, then horizontal louvers that provide sun shading over glass elements, and also green wall vines that can effectively, tie the landscaping on the ground into the facade. For the facade panels, we looked into this Equitone panel, which is a facade producer for fiber cement paneling, which is a ventilated facade and more climate friendly than a typical aluminium Cubond facade, because it needs less energy to be produced since it is a pressed fiber cement panel. It comes in different textures. And
to copy this tune, press 1.
Sorry, please. Would everybody mute their sound, their audio, please? Thank you very much. Yes, so you can see that we looked at different material selections. So you can see the glass panels that are shaded with horizontal shading elements, and then the other facade panels in between. Now, the question is how to make this facade paneling in the most efficient way. And for that, we have to take into account the manufacturer's standard sizes, of course, and how this would play out on the facade, and how these panels can be subdivided to give us the most aesthetically pleasing look, and also be efficient at the same time. So I will now lead you through different facade paneling iterations so that you can understand what this parametric design approach means for such a design task, such as finding the most effective paneling geometry. So this is one, more horizontal, more square, more vertical. And these different versions can all be changed through a few sliders in the Grasshopper program, and be easily changed. So this is the final one, a more vertical approach. And you can see that the panel comes in 3 meter size, 3 meter by 120, which means that it can be cut off in different panel sizes. So all these panel sizes that are listed here actually come out of one large panel. So the idea is that we can have different panel sizes, and then the panel sizes change throughout the building, but make up one whole panel. So you can see this example here, where we have large ones, and then it kind of transitions around the corner into a more square shaped design, depending on the sides. So we have the southeast and the northwest facades. And of course, the thickness of these panels and the sun shading elements make sure that the glass panels sit in well and are protected from the sun. So this is the final elevation. So you can see it is quite complex how these facade panels kind of move over around the corner to change their appearance, and also enable the facade to kind of fade out into a more industrial looking part of the building. So we have the more corporate looking part that then changes over to the more industrial looking part. And of course, this system can be applied to any kind of panel material. It can be applied to glass, to any kind of facade paneling. So it's this parametric BIM approach that enables a lot of flexibility to facade materials, whether it's glass or anything else. And this is now the final result. You can see how the glass panels and the other panels kind of fade out into around the corner where the building becomes less visible. So to sum up, what we've learned from this process is that parametric modeling as part of building information modeling can give us flexibility in the design process with easy iteration set up through modularity. So these facade panels are modular and can be therefore used in a very efficient and material saving way. So it gives us material efficiency, reduction of offcuts, and therefore a cleaner construction site with less waste. And of course, the cost saving potentials, because less panels need to be bought, less whole panels through the optimization process. So I thank you very much for listening, and I'll be available for questions concerning our work. And I'm looking forward to fruitful discussions and further presentations. Thank you very much.
Thank you so much for that presentation, Stephanie. I'm sure everybody liked it and everybody is very interested in your buildings. But you didn't mention the names of the buildings. Maybe you could mention some of the other names of the buildings that are in this, the end of the slideshow, so that they are familiar with your work. Okay, sure. So we have here on the top left the Freshport building, which was our first completed building in Lagos on Admiralty Way. Is in a quite good location, so many people might have seen it already. This one deals also with facade shading and a quite complex metal structure. So we are typically very interested in this kind of indoor-outdoor space, what facades and parametric modeling can do, and of course, how to deal with glass in architecture in this tropical environment. So shading elements and, you know, the spaces that can be used with natural ventilation are a major interest of our firm. You can see on the right here, the Freshport building again, the indoor-outdoor space, which is a shaded space with natural ventilation and a lot of green areas, which are still pleasant. And on the bottom here, we have a hotel design for an Asaba hotel, sadly not realized. And we have here the Joko concept store on the left, which also deals with modularity. It's actually designed as a flat pack modular building that can be packed up again and moved to a new location. And then we have this building, which is also a corporate headquarters, which is meant to be next to the building that I just described. I can't disclose any more details because it's confidential at this point, but they are located in Lagos. Okay, thank you so much for that presentation. I think we have all gained a wealth of knowledge from the short time that Stephanie has graced us with her presence. I think it's very important for us to be able to connect what Stephanie has discussed and what I would call the Sustainable Development Goals that the UN has advocated. There are 17 Sustainable Development Goals, and 11 of them are represented in the International Year of Glass celebration. What is particularly interesting for me in what Stephanie has highlighted is the aspect of these sort of sun shading devices. It's important that we are very cognizant of the fact that there is what we call climate change and global warming, which reflects in so many ways, especially in the cities where we have the phenomenon of the heat island effect, and also for the internal conditioning of our spaces. We find now that we need to continually increase the capacity of our air conditioning. And it is quite important that we must find a mix between mechanical interventions and the natural systems of our buildings within their context. I think this is very, very important going forward. And building information modeling offers a very, very good tool so that before you make the mistakes of actually building a facility that you need to have excessive cooling mechanisms installed, you might want to correct those mistakes, so to say, by modeling it. And by modeling it, we're talking about getting your software correct, getting your material specification correct, knowing about things like embodied energy, recycling, reuse of your materials, and knowing how your building will perform in its context. So I want to thank you so much for this. And please, if you have any questions, put it in the chat box. And I think we'll go to the next speaker, which is Dr. Shotubo of the Building Department of the University of Lagos. Thank you so much, Stephanie. And I hope you can stay on for as long as you can. I know you've got a busy schedule, but we'll hand over to Dr. Shotubo for now. Thank you again.
Thank you also.
Thank you very much.
Dr. Shotubo, are you on? We can't hear you at all.
Because he is major.
All right, can you hear me now?
Yes, we can hear you now. Thank you. But you need to start from the beginning.
Yes, I will.
Hear you at all.
Okay.
Oh, the water is inside.
I didn't put the water there.
Okay. Just allow me to share the screen.
Base is always dirty because we put the base on the table. You put it on, on surfaces. So it's wrong to now put another cup in it like this. When you put another cup in it like this, you get the base of this one.
All right. Can we all see my screen now, please?
Yeah, we're seeing your screen. You are on.
All right. Thank you so much. Thank you so much. Thank you so much. Thank you, Architect Kulaja, for giving me this opportunity. And thank you, my Dean, Professor Modupe Omiri, for this opportunity. And I've also seen my HOD, Professor Ame, in the house. Thank you, sir, for this great opportunity. And thank you, everyone. Thank you, Stephanie, for the well-enlightened presentation. Yeah, today I'll be speaking on BIM, basically, as it relates to glass. Mine aspect is more of a theory, bringing up the theory and then gravitating it onto the practicals. All right, so I'll be going through these lines of thought. First, the introduction, then what is BIM, building information modeling, then project life cycle in BIM. Also, I'll be looking into BIM tools and the Ds of BIM, then adoption of BIM, the world view, benefits of BIM, barriers to BIM adoption, BIM in Nigeria, challenges of BIM in Nigeria, the way forward. Then we'll be looking through some sample projects with BIM application in Nigeria, and then glass in BIM. And thereafter, I will conclude. So the introduction. We all have the understanding that there is what we call the traditional method of construction, which is more like the basic of a construction method in the construction industry. And this is well practiced in Nigeria. We have the traditional method, we have the project delivery method, and all other types of project delivery system. But the traditional method is plagued with some challenges, which are not just peculiar to construction industry, they are peculiar to every aspect of the economy. The cost overrun issue, the time overrun issue, the poor quality of job delivery, safety issues on site and the likes, then job dissatisfaction, and then loss of profit eventually to the contractor. So all these issues are peculiar to traditional ways of handling projects. And also, when this happens, they eventually leads to what is called project abandonment. When clients are dissatisfied, they tend to abandon the project, and then also will lead to fragmentation among the professional individuals in the project. When one is trying to make his own opinion superior to the other, or when one is trying to agitate his superior, his opinion. So there could arise fragmentation, which could lead to unsatisfactory coordination along the production line. So all these issues are what affect the delivery methods that we have in the construction industry. So, and of course, these issues are not synonymous to construction industry alone. They are there in the automobile industry, in the textile industry, and even in the banking industry. So, job dissatisfaction now necessitated research into how to deliver projects that can be satisfactory, that will be within cost, safely executed, within time, and then every party involved will be happy. And so when digitalization came into existence, we've seen it in the banking industry, how it has shaped the mode of operation in the banking system, taking away queues on in the banking hall, and then making everybody being able to access banking services from wherever they are, without necessarily going into the bank, crowded the bank, and so on and so forth. So people can work remotely. And so this digitalization have helped to bring about tremendous solutions to other sectors. And so in the construction industry, researchers now felt the need to bring this digitalization into the construction industry to ease off in the way we deliver projects so as to make it more efficient and then more satisfactory. So BIM, Building Information Modeling, is actually a platform, is a tool to help us achieve these means in which all professional bodies come on a single platform to operate. So as an integrated system, the innovation brings solutions that help to curb inefficiency within the system, and also enhancing information stream among stakeholders involved at all stages in the architecture, engineering, and construction industry. So therefore, what is then building information modeling? Building information modeling is a highly collaborative protocol that allows multiple stakeholders in the construction industry to collaborate on the planning, the designing, constructing, and the whole life cycle of a facility within a digital framework. Now, we have to take note of collaboration protocol. So it's a process, it's a protocol on its own that enables professionals to collaborate in the planning, designing, constructing, and the whole life cycle, not just stopping at execution of the project alone, but the whole life cycle within a digital framework. It is also an information management method for construction projects based on the use of digital models across the entire life cycle of a building facility. So we are talking about digital system now, digital models embedded on a single platform where several professionals can interact, can interface towards successful execution of a project. It is also seen as a technological aided design, engineering, construction, and operation of built facility. So, as I said earlier, it goes beyond just the designing and construction. It goes into operations of the said facility. It integrates multidisciplinary data to create detailed digital representation that are managed in an open cloud platform for real-time collaboration. Of course, it is used for creating and managing data during the design, construction, and operation process of the facility. With that said on the definition, now looking at the typical project life cycle in BIM, just like the traditional method, there is a project life cycle. We have said that this method goes beyond just the construction aspect. It goes into the life cycle. So this one encompasses also the life cycle's operation. I mean, the operational aspect of it. So we have the conceptual design, which talks about visualization, just as what Stephanie presented. We've seen a lot of visuals effects, a lot of different shades of the facade. These are what are brought up at the conceptual and design stage. And so at design stage, we now go more into coordination, cost estimating, simulation, analysis, just as she presented, and then taking off and rendering. And after all these are done, then the construction process itself. And after the construction process, we go into operations, which is all about facility management, maintenance, and repair. And then we can have modification or even demolition, which marks the end of the life of such building. Should we want to retrofit the building? Should we want to recycle, remodify, or total demolition to start a new one again? So in BIM, this is the project life cycle. So what are then the BIM tools that are available within the construction space? The BIM tools a model-based process that allows a professional to plan, to organize, design, and manage the construction process. They are tools, they are software package, they are models. So for design tools, we have AutoCAD and SketchUp, just to mention a few. And for structural designs, we have RISA, STAAD.Pro. For mechanical and electrical tools, AutoCAD MEP. For BIM construction tools, of course, Revit, ArchiCAD. And then construction management tools, we have Procure, Navisworks. For cost management tools, we have Press and Stack, and so on and so forth, even on to facility management and safety assessment. Now, what are the dimensions we have in BIM? Presently, we are operating at the 7th D, but researchers have shown that we've now moved past the 7th D. We are now going on to the 10th D. So first, with the 7th Ds, the 2D is the CAD, the computer-aided design. At this level, what we do purely is just to use computer-aided design to replace the manual designs. And then we move to the 3D dimensions, which involve the modeling, rendering, the geometrical designs, and graphical information, imputing all these things in a digital framework. And thereafter, we move into the 4D, which is time-related information, time-related model. The Gantt chart of this world are models that are now embedded in the BIM platform, so that when a model is produced, we don't have to go outside the model again to prepare the program of work. Right on the BIM model, a program of work can be generated for the model created on the BIM platform. And then we move again to the 5th D, the 5th dimension, which is about cost data. This also incorporates cost management softwares and cost estimating software into the BIM platform. So when the architect designs using the 3D and all whatnot, and then the programmer can produce the time-related documents, the program of work, when the cost information has already been produced through the same platform. And then the 6th D is talking about the sustainability, just like what Stephanie presented. From design, we can see the orientation of the building. We can see the best position the building should be located to maximize the impact of the sun and reduce it at when required. We can see, and we can even go further to know the energy efficiency level that the building will offer. So at this level, a lot of softwares, a lot of tools are embedded in the BIM platform to be able to accomplish this: energy efficiency, energy rating systems, and so on and so forth. She's talked about edge. If edge is embedded on the platform, even before construction, we will know whether the building will satisfy edge criteria. And then the 6th D talks about the life cycle and maintenance, which is all about facility management. So it is not just for the building to be constructed and then handed over, it is also to be managed. So BIM tools also have a capacity to help in management of the building, post-occupancy management. So the 7th dimension deals with that. And then we have the new dimension that are being brought forward now. Discussion are ongoing, and this is on the 8th dimension, which is talking about safety. A project delivered unsafely will be termed unsuccessful because there will be a lot of litigation. on it. We are experiencing collapse of structers in Lagos State. Safety is key. People are losing their life. The project at the 21-story building is about to be brought down now. The other part. Why? Because it has been turned unsafe. So the 8D talked about safety. And then the 9D, the lean construction, how to construct economically without wasting too much material, without wasting money, and still delivering the project as at when due. And then the 10th D talks about construction industrialization. So these are the dimensions of BIM that we have. Now, BIM adoption, the worldview. This is looking at the world scenario. Now, BIM adoption across the universe varies from nations to nation, continent to continent. Okay, some are already at advanced stage, while some are still evolving. In Africa, a lot of African nations are still evolving, while European nations and American nations, the North America, they are all already advanced in the adoption, because this model originated from them. So they have gone way ahead of every other country in it. So some nations around the world already have even roadmaps on BIM app adoption, dated back decades ago. So we have Singapore. The first roadmap was brought up in 2004. And then by 2010, they reviewed it again and stepped it up. In Finland, it was 2007. And then by 2012, they reviewed it again and stepped it up. And in Korea, it was 2010. In the US, they brought a roadmap up in 2003, and by 2007, they reviewed it. And as at present, they have 80% adoption level in all their federal government works. So if anyone wants to work in the United States or at a federal level, you must be ready to adopt BIM to deliver the project. And in the UK, they brought out a roadmap in 2011, and 2016, they said they even want to move to level 2. They even have a level ramp. Not just the dimension, they even have a ramp that they are following, that they want to move to level 2, which is the third stage on the fourth level of the ramp. And they have about 73%. And so they said by 2016, every project that must be delivered within the government setting must be delivered on BIM level 2. And then China also came up with its own roadmap in 2001, and by 2011, they revisited it and they reviewed it upward. And they have about 67% adoption. Australia, 2012, and they have about 70% adoption. Now, this is the ramp that UK government adopted. They call it BIM maturity ramp. So we have level 0, level 1, level 2, and level 3. Level 3 being the fourth level and the highest so far. So as of 2016, they moved away from level 1 and are now operating on level 2. So level 0 is about CAD system, where we move away from the hand drawing, the paperwork, the hand drawing, onto using CAD to produce drawings. The 2D, AutoCAD, and other CADs to produce drawings. And then this is paper-based. The depth of information exchange is based on paper. So the architect produces the drawing, prints it out, and sends it out to the structural engineer. The structural engineer prepares his own drawing, prints it out, and sends it to the cost engineer. And it goes on like that. So the coordination and collaboration is paper-based. This is level 0. Now we have the level 1, at this point, we now have 2D and 3D working together. And so the exchange format is no longer a paper-based thing. It is now using proprietary formats, that is, different softwares that can do the job, that can produce 2D drawings, different software that can produce 3D drawings. So it doesn't have to be AutoCAD alone. SketchUp can do same, ArchiCAD can do same. So different formats are now coming into play. And then the depth of information that are being exchanged is about geometric model, nothing printed on paper. Everything is soft. Geometric models. And then the collaboration is file-based system. So no paper printing, no paper sending. It's all about send a file, uploading it to the cloud. We go to the cloud, we see it, and then we continue the work. And then the level 2 talks about the federated BIM. This is where the full BIM capacity is now being engaged. So at this point, we synchronize different models, 2Ds, 3Ds, and other tools together. So it is more robust than the level 1 proprietary format. Is a more robust system. And then BIM specific models are exchanged. They are not just drawings, they are not just elevations, they are not just plans, they are BIM specific models. Just like Stephanie presented, those information presented are beyond what ordinary CAD system can do. And then it is centrally managed. Centrally managed. So at the central point, everybody access that central to get the information, and then you upload your own information onto the central file. And so it is open. And then the level 3, which is the third, the most advanced level, at this level, we use the big open system of BIM. Now, the BIM open system is a system whereby any tools can work once the protocol is accepted. It is not closed that, oh, it is only AutoCAD that can work on that system. No, it is any models. Once the protocol is accepted on that platform. So AutoCAD can come in, SketchUp can come in, Revit can come in, and several others that are still coming up can be mounted on that platform based on ISO standard. And so integrated data models are used throughout the entire life cycle. So it is not just the drawing, it is an integrated, interoperable building modeling, building information models are now exchanged. And these are now managed in a cloud-based system. So everybody access that cloud, you do what you want to do, and as you are effecting it on the cloud, the other parties are seeing it. The effect is immediate. Once the design changes, then the cost person affect the cost, and everybody sees it on the cloud system. So this is the highest level that UK government is proposing in the nearest future. And a lot of other countries too are trying to adopt this ramp maturity. Now, on the continent of Africa, according to Africa BIM Report 2020, out of 54 nations of Africa, only 30 took part in the research. We can say from that just fairly above 50% of the nations in Africa are trying to work on BIM. because the rest did not take part. And so leaving the response rate to about 56%. And this study shows that awareness rate is about 90% prior to the survey. Oh, do you know what, are you aware of BIM? Yes, they say they are aware, they know what BIM is, but only 50% out of the 30, which represent 56%, meaning only 15 nations in Africa have implemented BIM at varying levels on their project. Now, this is not even at national level. The professional they asked said, oh, they've implemented BIM at 1 or 2 projects, not even at national level. So 50%, meaning 15 countries out of the 54 nations in Africa have some sort of implementation of BIM. And of course, South Africa is said to be leading in that regard. Now, we talk about benefits of BIM. I grouped it under pre-construction, construction, and post-construction. So for the pre-construction, adoption of BIM enables better concept and visibility of the entire project frame from conception to operations. So it enables better concept, it enables better visibility. Stephanie presented the facade of the building she is working on. We can relate with it. We can see the effect of sunlight at different position. So if you are not satisfied, we can easily pinpoint it out and say, oh, can we do it this way? It seems there will be more heat at this point. Unlike when the building has been finished, and then we are now feeling heat, which now leads to high energy cost to cool the building down. Also, effective site analysis to understand environmental and resource-related problems. We could also see it in what she presented. From that analysis, we're able to know the direction of the sun. We're able to know the best direction to locate the building, to maximize to maximize shading, to maximize the wind direction, and then reduce the effect of the sun. So implementation of BIM at pre-construction helps to achieve this. It also helps to improve efficiency and accuracy of existing conditions. Existing conditions documentation. If you want to document what is on ground now regarding the site, we have it. We can achieve it on BIM. Also, effective design reviews leading to sustainable design. With what Stephanie presented, we could bring up some questions. We could say, oh, why not this way? Why not this way? So design reviews can then lead to sustainable designs. It also enhances energy efficiency during design stage and resolve design clashes early through visualization and model. Through visualizing the model, so we can resolve clashes. What is not constructible, we can quickly see that this thing cannot work here. Yes, it is designed to work. Can we all reason at it? This column shouldn't be here. This beam shouldn't be here. Through visualization, working through the models of the building, we can actually see all these clashes, all these issues that can come up at construction stage and immediately rectify them while still at design stage, and not allowing to get to the construction stage that we now need to demolish and rebuild again, losing money, losing time. It also integrates construction process into one. It enables visualization of the proposed project, enables faster and more accurate project time and cost estimation, provide digital model with data that can be utilized throughout the whole building cycle. All this information that are presented by Stephanie will be stored. So when in the nearest future, a maintenance is required to replace any panel, we can quickly go and see what are the characteristics of those panels. What are the design elements that makes up that panel? And then we can use it to order and then replace, and it will fit well. So it improves team building skills because we now have to work together as a team on the same project. Improve project documentation, improve multi-party communications and collaboration, minimize errors and mistakes, and better synchronization. At construction stage, it makes evaluation of the complex building system to improve planning of resources and sequencing alternatives. It also enables effective management of project resources. Because all these things are on the same platform. So we know what we need, we know the quantity of what we need, we know the time we need them. So we don't just bring a material to site when it is not needed. We don't just bring excessive material to site when we needed 2 cubic meter of sand. We don't just bring 10 and then the rest will be wasting until the next time we need them. So it improves efficiency and productivity. It also enables efficient fabrication of components off-site using design models as the basis. So if you have to fabricate materials off-site or any component off-site with BIM and the 3D version, we will be able to see the components, see the different geometry of the component, and then this can help fabrication without making errors or mistakes. Of course, it also eliminates clashes during construction. Why? We detect clashes on time and we resolve it. And then it improves project quality, because at the end of the day, the quality of what we produce will be better. Provision of accurate and updated information. Since everybody have access to the information, and any changes made is effective instantaneously on the model. So once the architect made the changes, it will be obvious to the cost expert. It will be obvious on the program of work. And so project information are accurate and are updated frequently. It reduces rework on site, because once we know what we want to do, we know the geometry, the dimensions, and everything that we need to do, we won't make mistakes in doing what is not right. We won't make mistake in doing what is not right that we now need to redo again. So access to information is faster and reliable. We don't have to be waiting for a consultant to come to site before we can have an information. Oh, I'm printing the document from my office, I'll be sending my staff to bring it to site. No. We just go to the cloud system, and then we see everything. As the architect is making the changes in his office and is uploading it, we are seeing it immediately on site that, oh, something has changed. So it also enables us to monitor and track progress during construction, better site utilization, reduce site congestion, and improve better safety on site, improve project documentation, consultability improvement. It minimizes disputes. Once we have no argument about what is to be done, how it is to be done, how much it is to be done, then there won't be dispute and conflicts on site. And then better buildings and infrastructure delivery. And now to the post-construction benefits. So data in BIM model help decision making about operations, maintenance, repair, and replacement of components. with the presentation by Stephanie, those panels now, we know their geometry, we know the data, we know the dimensions. We even know where to get them, the manufacturers that make them, the specification we know. So if we need to repair or replace any part, say in 10 years' time, we know where to go. And even if that same material is no longer available, since we have the information, we will then look for a material that is close to the data, that can function in the same capacity. Unlike when we don't have those data, and then we need to replace any element, we'll now be saying, oh, where did they manufacture it from? Who brought it to the country? Oh, what is the energy efficiency of the material? We don't know all those. Then we just go and bring anything that looks like it and bring it into the building. And then the energy efficiency of the building changes. Also, it makes asset management faster and more accurate with more information. Ability to schedule maintenance and ease access to the information and ease of access to the information during maintenance. It also helps with greater energy efficiency. Now, barriers to the adoption. This now is about general barrier. We are still coming to Nigeria, the Nigerian situation. So here, high cost of investment. It is technologically driven. And so we know for now, the cost of technology is still on the high side. So high capital investment in terms of those models, those tools to bring them all together, the subscription, they are high capital intensive. Because these things are, they are developed away from our shores. So they are in dollars. So getting them is very expensive. And then we have the industrial cultural resistance, industry's cultural resistance. We are good with the way we've been doing it. We have no issue. We are managing our issue. So why step up again to something that we are not used to? So resistance to change and sufficiency of 2D mentality is still a barrier to adoption. Then low level awareness of BIM benefits. People are aware of BIM, but the benefit it offers, they still can't relate with it. Then inadequate training on the use of BIM, insufficient governmental support. And then we have legal issues about ownership rights. So who would then be the originator? If you have a BIM platform that everybody interrelate, so who will then own the system, the entire system? Where will it be domiciled? Will it be domiciled with the architectural professional? Will it be domiciled with the cost expert professional? Or will it have a separate management away from this professional that will have the ownership? So ownership issues. And then increase in professional charges due to BIM usage. Because it is capital intensive, so any organization that is able to implement it will charge more. On a lighter mode now, what Stephanie will be charging on the project she's handling will be different from someone who is just using the 2D and then paper drawing to execute the job. So professionals will charge more once they are implementing that system because it takes more to implement. Then lack of support from top management of those organizations, okay? So when they too sees that, oh, clients may not want to pay, then they wouldn't want to adopt it. And so this also increase the barriers. Then doubt about return on investment. Everybody wants a return on investment. Every contractor, every client, they are in business to make business. And to make business, they must make returns. So if they are not sure that, oh, if I step up to BIM, I will have return on my investment, they wouldn't want to go into that. Then lack of BIM experts. lack of clarity in the industry of what we want. Do we want BIM or don't we want it? Some want it, some don't want it, some are neutral about it. So we are not clear about the direction we want to take. Then longer process. Conceptual time may somewhat take a longer time to develop all these models, to relate them together, to make sure they synchronize. It takes a longer time. So people say, no. With the traditional project method, we could even have gone to site. We could have started work. Why design is still ongoing? Why should we have to wait till everything is set at design and then we move? And then absence of constructual requirement for BIM implementation. Complexity of the BIM model, because new design, new tools are coming up, and though they seem simpler, but we still feel them that they are complex in operations and so on. And the interoperability between software programs. If program A will not work perfectly with program B, then we have issues. It becomes frustrating. And that is why the big open BIM system is not developed. That once the protocol from the programmer, they will have made sure that that software can work on the platform, so as to eliminate the interoperability between software. The lack of standardized tools and protocols. So meaning that anybody can just bring in a tool and say, this is what you have just developed and it is compatible, and then here we go again. So lack of government policy and direction. Now, BIM in Nigeria. The Nigerian construction industry is said to be notoriously conservative and slow to change, according to Kadiri and Omishak in 2020. And this being faced with countless challenges in the implementation of traditional procurement and other delivery methods. We have issues in the construction industry, and still we don't want to change. We are conservative. Why? Because we are so comfortable with that system. And therefore, the adoption of BIM is considerably low, as awareness is moderately high. Adoption is low, but awareness is moderately high. Because yes, we know about it. We are on this platform talking about BIM, so we are knowing about it. But now when it comes to adopting it, implementing it, that is where the problem lies. That is where the main challenges shows up. But just knowing it, being in a seminar to talk about it, yeah, we can all go to seminar, we can all afford to listen and be aware about it, but implementing it becomes an issue. So implementation is very low. And in Nigeria, about 22.8% implementation we experience, and about 60% awareness. So there are just few projects here and there that adopt different levels, I mean, to a certain level of dimensions of it, of BIM, that have been implemented. And so once you are on, say, the 3D, the 4D dimensions, of course, we say you are adopting BIM. It does not necessarily mean that it has to be to the 7th or to the 10th. So the challenges, specific challenges we have in Nigeria is that we have a rigid industry culture. We are so used and so comfortable with the traditional system and all other methods that we are using, that taking BIM up is a bit of a problem. And then fear of job loss. We don't want to lose our job. When we implement this and everything becomes digital, then the staff that goes from office to deliver the project document at office will lose his job because there will be no job for him again. And several other things like that. So fear of job loss, the low level of awareness. Yes, the awareness is there, but it's still considerably low. The reluctancy and lack of technical skills from professionals in the industry. About 15 years ago, I stand to be corrected. Maybe it's only AutoCAD that we have, even in the educational sector, where professionals are being trained. Maybe just in the last 10 years or thereabout, that the skill is now becoming more and more appreciated. So the older generation of professionals, they lack the skill. Even the new generation of professionals, they still lack the skills because most of what we do is about knowing about the barriers, the challenges, the benefits, the advantages and disadvantages are what we teach. Now, we need to make sure that at institutional level, the students are exposed to the usage, to the practical aspect of being, not just knowing about the advantage and disadvantage and increasing the awareness, whereas the implementation is going down. Then startup capitals and sustenance, of course. We have economic issues. So getting a software licensed is a problem because these things are in dollars. So what is the volume of the work that we have and the cost of it to compare to the licensing fee that you have to pay annually on those softwares? So startup capitals and sustenance is a problem. And then we have high professional fee. Of course, those professionals that are able to adopt it and implement it, they will charge more because they have to pay subscriptions, they have to pay and to maintain it. So high professional fee is not a problem. And then we have policies and legal issues. And then the backbone of it, lack of viable ICT infrastructure. This system called BIM is digitalization, is digital system. And digital systems are run by ICT infrastructure. So one of those infrastructure are not viable enough. Even to transmit, to upload information, once it becomes a problem, it can be frustrating. Whereas in some other cloud, at a tap of the button is uploaded. And in some other part of the in some other cloud, climate, that internet is not up and doing. You strike a key, you have to wait for it to go round and go round several minutes before it is uploaded. It can be frustrating. So lack of viable ICT infrastructure is also a problem in Nigeria. Also, incompatibility and interoperability issues. Software are not compatible with one another, then we have issues. Oh, the one I am operating is only Revit that works perfectly on it. You bring in SketchUp, you have issues. And all these things causes barrier. The lack of adequate training and cost of the training. Even when we want to do the training, if it's so costly, then we will run away. Low buy-in from clients, even when we are ready to invest this time and cost, if the clients are not buying it in, if the clients are not encouraging the professionals on application of BIM, then whatever knowledge we have on it will be truncated because clients are not ready to pay for it. They're not ready to buy it in. They would rather patronize someone who can just do 2D for them and that will be fine. Or maximum, just give us 3D and print it out and that will be fine. Don't bother putting it on any platform that I'll be seeing it, you'll be seeing it, I can monitor, you can, no, don't bother. I'll come to site myself to do the monitoring. So all these issues are because of economic reasons. Then uncertainty on return on investment. If clients are not going to buy into it, they are not going to pay for it, then how do I recoup the investment? So if this can be solved, then we leave it. The affordability and availability of software packages. Because these software packages are sold in dollars. They are developed and sold in dollars. So exchange rate becomes a problem. We can't afford it. And since there are no local developer that can develop these things and price it in local currency, so it becomes a problem. If you have to pay for subscriptions for and so on in hard currency, the lack of power supply is a critical problem. If you're uploading something on a server and then there is power failure, for you to reboot the server again, all the information will be lost. So if we don't have adequate power supply, there will be a problem in implementing the model. It then means that to even implement it outside adequate power supply means that we must have alternative power, which we add to the cost of implementing it. And then corruption and transparency issue. In the traditional way that we run construction, it allows for corruptions and lack of transparency. One can say, oh, I have placed 2 cubic of concrete, whereas he hasn't done up to that, and he wants to claim, I have placed 2 cubic meter of concrete. Oh, I have done this, I have done that, but because we can't open up the built system, the built structure to see what he has done, then we have issues. Oh, we have taken 50 tons of sharp sand to site, and by the time the QS get to site, they started using it. Then he will have an issue of how do I now make sure what you said you brought is what they're now using. They say we will use 10 cubic meter out of it. Whereas the guy hasn't brought up to that. So lack of transparency, corruption on site and off site affects implementation because we want to thrive at that level. So that is where contractor makes more money. And so once BIM comes into place, all those things will no longer be available. So what are the way forward? We've known the challenges. So how do we? And we have also known that BIM is the way to go. If we have to reduce inefficiency, if we have to bring in transparency, if we have to bring in quality delivery within cost and time, BIM is the way to go. And so the way forward for Nigeria is to have the regulatory and professional bodies to facilitate the digital shift. In all these countries that we talk about, the UK of this world, the US, China, professional bodies came together to drive this. And professional bodies and regulatory bodies serve as advisory to the government. So government may not know all these things because government are made up of politicians, but professionals advise the government, this is the way to go. To reduce cost of government projects, this is the way to go. Let's have a framework that everybody will work with. So professional bodies and regulatory bodies must come together to drive the shift. And then educational development and training. Just like what we are doing now, we are developing ourselves. And it must go straight down into our institution. we must do more than we are doing now. In fact, at this level, we must have hands-on implementation, even within the educational system, that the architect student will collaborate with building students, with structural engineering students, with QS students, to digitally work on a project and deliver it virtually. That is implementation. So they will now see, oh, how it is really being implemented, not the advantage and disadvantage of this word that we know, not the pure awareness that we are dealing with. And then when they get out there and they're about to now to implement this thing, they will be able to maneuver between these the tools. Not that one will just understand AutoCAD, Revit, and that is it, without knowing how to maneuver within other tools. So educational development and training is key, even into our schools, and then increase organizational willingness and support. Aside from regulatory bodies, even organizations, client organizations must be willing to support and drive this. For instance, bank is a client organization. If all the banks in Nigeria come together to deliver a project for them, whether they are head office or branch office, it must be implemented on BIM. The contractor will have no issue than to go and invest on it. And meaning that the organizations or the client organizations that brought down those policies, they also are willing to pay for it. So the contractor and the other professionals that needs to work on that project will have no choice than to invest and develop on BIM. So organizations must be willing to support and drive it. Then there must be policy direction from the government. Government brings up statutory framework, so governments must bring out a direction. The UK government, before 2016, they came up with a direction in 2011 that by 2016, every project that must be executed for government must be on level 2 BIM, on the BIM RAM, level 2, regardless of the dimension you are using. If your dimension is not level 2 compliant, you are not getting the job. So everybody then have to step up to make sure whatever dimension that you are comfortable with steps up to what level 2 can take. And now by 2016, they achieved that. They are not thinking of stepping up again to level 3, which is the final level. There must be government direction. If our government is not giving the direction, then everybody in the professional, in the industry, will just be doing as they like. And then there will be slow pace of adoption. Then development and adequate security in the nation's ICT architecture. Our ICT architecture needs to be rigid, needs to be reformed, and needs to be a top-notch one to be able to drive BIM. And of course, stability in power supply. And then local BIM content or tool development. We must encourage local scientists, local developers, software developers to bring up BIM tools that can be affordable and within our own client, and can then be affordable and can even be sold to the outside world. So we must encourage local BIM contents and tools to be developed. And then there must be cultural change in the industry and elimination of corrupt practices. Now, some sample projects with BIM application. G+BIM is the #1 implementation of BIM in Nigeria as of today. From my studies, they've been able to adopt even all to the 5th dimension, and they're trying to implement it on some highbrow projects. Now look at that, on some highbrow projects. So not on just any project that can pay for it. For instance, this is the new headquarters of the Office of the National Security Advisor of the Federation. It's just a 4-story building with several other security buildings around it, and they are delivering this project in Abuja through BIM. It's about 15,000 square meter floor area and a multi-million-dollar project, an office complex. So he can, with a multi-million-dollar project, they can afford to implement BIM on it. All those softwares, all those tools they need to use, they can afford to pay for it, afford to host it in the cloud and pay for it. And then they still made their profit. And because this is a government project, government pays for it. And so the BIM implementation wasn't from the direction of the government. It was from the direction of the contractor, because they are the designer and the contractor. So they are delivering the project. So they are in control of the conception, of the design, of the construction, and then they hand it over to the government. So they are delivering, they are using BIM onto the 5th. That is, they are using the time dimension of it to program it and manage it, and then the cost dimension to make it more cost efficient. Of course, the operation aspect of it, they hand it over to the government. Our own is to conceive, design, build, and then hand it over to you. So they are not implementing the 6th dimension. And also, the G+BIM Stadium Complex, delivered by G+BIM as well. And this is the 3D version of this stadium. This is an G+BIM state government project, and they also use the 5th D dimension of BIM to implement this. Only, of course, the model, which are in 3D, and then the cost, the logistics, and then the time management aspect of it, they embedded in a BIM platform to deliver this project. Of course, operations and maintenance, they hand it over to the government. The government takes, but every information needed, every information that made up the project available on the platform. So even for maintenance, they just need to visit the platform again and see, okay, for the shell, what material, what are the characteristics of the material? Then they can order for it and then replace. And then another important thing about this pitch is that glass, acrylic glass, was used for the facade, about 14,000 square meters of it. And so this is implementation of glass again in BIM. These are just other information about the stadium, and the stadium was actually delivered 2017, and several matches have been played, meaning that the stadium is still performing. These are the 3D and the under construction view of the stadium. And then the next one is Eco Atlantic, the Victoria in Victoria Island, Lagos State. The new city being built is being delivered with BIM. Of course, it's a multinational client, so they can afford to pay for it. Stakeholders are multinationals, consultants are multinationals. So international standard is being played here. And so contractors here, G+BIM, ITB, Kappa and Dabato, and several other multinational contractors are delivering this project, and they are relating through BIM. Julius Badia also said they are using the 5th D to implement this project. But the major financier wants more. But for now, they are using the 5 dimension just to execute, while the operation and maintenance will kick off later when more of the projects are now coming up. Of course, these are just some information about the project. Now, adoption of glass in BIM. We have seen several international glass manufacturers incorporating their products on BIM for ease of access and ease of selection. For instance, AGC Glass Europe, they have a plugin where all their products, sizes, geometry, energy efficiency details, all the details about their product are incorporated into that plugin, and that plugin is on BIM object. So as you are designing, you just use the BIM selector and you select the material and you apply it. And once you apply it, the software will give you all the characteristics of the kind of glass you have picked, the energy efficiency of it. And then once you are done selecting, you can quickly run. If you are on the energy, the sustainability dimension of it, you can easily see the environmental friendliness, the energy efficiency that material you have selected can give. If it's sun reflective, you can see what amount of sun is reflecting. Just as Stephanie presented. And so they have all this data on their plugin and they are on BIM platform. So whether you are using Revit, you are using ArchiCAD, there is an AGC plugin that you can activate. So if you need to use glass from AGC, you don't have to be looking for their brochure any longer. It's there. So once you just open it up, you pick the sizes, the type that you want, and you incorporate it into the project, and then you can see how the glass will perform. And also we have Guidance Glass North America. They too also have the same thing. As AGC is doing, they too are doing, and several other manufacturers, they are now bringing their products, catalogs, and information on BIM platform so that professionals can pick these tools and use them to achieve their desire. In conclusion, we have said that BIM is the way to go for efficient collaborative project delivery. In Nigeria and in every other part of the world, BIM is the way to go. Of course, we know that few projects are being delivered through BIM in Nigeria, and these are done by top contractors. Top contractors with top clients are the one somewhat applying this system in Nigeria. Though awareness is high, but adoption is generally low within the country. Of course, we also know that BIM offers huge benefits to the construction industry, but its barriers are also enormous within the Nigerian state. And then more needs to be done across board to enhance its full implementation in the Nigeria construction industry. And then these are some of the reference material for this presentation. Thank you for listening. I also await questions. Thank you. Thank you, Architect Okulaja.
Thank you so much, Dr. Shotubo, for that fantastic presentation. I wish everybody that is not here would have heard it. And this time that ASU is actually on strike, I want to give you a double commendation again. It is important that we all strive to continue to keep the flag flying. And I want to thank especially Stephanie, who has indicated that she has to leave, but this event is being recorded, and I believe that she will still get the full gist of it even after the event. I have Professor John Ame with his hand up. I don't know whether he has a question. You can please type your questions in the chat box, but if anybody would want to ask a question, you can put it in the chat box. The only slide that we will not be sharing is the one with that Stephanie Adisa presented. You can only view them at the recording. So we'll put this out on social media. And if you want, you can go back to the recording as many times as you want to get the information. Thank you. So any questions, please? I can't hear you. Any questions? If you cannot speak up, you can put your question in the chat box. In the meantime, I would like to invite the representative of COSTECH to please prepare for their presentation. We have had quite a long event, and we're actually on schedule based on our plans for this event. You can take time to stretch your legs a bit if you are able to, but I don't think you want to miss this presentation from COSTECH. It is very, very interesting, and I wish everybody happy listening. So over to you, COSTECH.
Okay, thank you so much. I'd like to share my screen now.
Cyril, over to you.
Yes, thank you so much. I would like to share my screen now. Just give me a minute. Okay. All right. I hope you can see my screen.
Yes, we can.
Okay.
Yes, we can see your screen. Thank you.
All right. Thank you so much for. I would like to thank the other presenters for their amazing work they have done. I think the last one was quite intensive. We covered almost the things that I have in mind to say, which is amazing. So I will go into the presentation properly. Before I do that, I would like to talk about who we are. COSTECH Computers Limited is one of the leading partners in the software solution and BIM implementation. We are Autodesk Gold Partner in Nigeria and also Authorized Training and Certification Center Partner. We also partner with other software solution companies like Bentley, Archidesk, Oracle, SketchUp, Chaos Group, Cloud ABBA, Our company has been working with businesses for the past 7 years in BIM implementation through consultancy, support, and training services. So I would like to probably, after the program, drop our website link. You can just check it out. If you have questions, you can contact us. If you have any inquiry, you can also reach out to us. So I'm going to see how we cover this. We're going to talk about the BIM definition, the collaboration, the element of BIM model, dimensions, and the BIM tools. These are the areas we're going to navigate towards BIM. Like the last presenter has rightly said, BIM is the way to go. BIM is the future of work. But the question is, I think he has actually explained this, what is BIM? But I would like to go back to that. I would like to also cover that. So what is BIM? BIM is building information modeling. It's an intelligent 3D based process. Now, when he's explaining, he explained about the workflow as regards to conceptualization to operation. Now, the BIM is a workflow on its own that has other softwares attached to it used to implement the workflow. We have a lot of softwares that are used to implement the workflow, but BIM on its own is a workflow or a process. Now, the most important thing about BIM is the information. What are the information that we need in this implementation? And that is what BIM is all about. How are we able to manage this information? Building collaboration between all project stakeholders means they are all getting the right information at the right time. We're talking about connected BIM, being able to connect all the industry stakeholders, people that are involved in a particular project, starting from the conceptualization to the operation. How do we bring them together? BIM has created that avenue for us to bring together all these stakeholders together and give a platform whereby they will be able to understand what each engineers are working on their particular space. If there is any modification that should be done, it will go all around. So BIM creates that opportunity for us to have a single source of truth, connecting all the industry stakeholders. Like I said before, it creates that one database of information where every stakeholder in the project can go in and get information on what is happening on a particular project, starting from the conceptualization, the design, the planning, the construction, and its operation. Now, I would like us to go through this video. I don't know if we have much time, but I would like us to go through this video to understand better what BIM is all about.
BIM. You've probably heard about it. And you may know that today's architects, engineers, construction professionals, and owners are using BIM from small or seemingly simple projects, like a building or roadway, to complex multidisciplinary projects, like a major urban development, and everything in between. But what is it? What is BIM? BIM, Building Information Modeling. At its core, is a holistic process for creating and managing project data within an intelligent 3D model. From plan and design to build and operate, it's much more than a single tool or technology. It's the foundation for digital transformation in the architecture, engineering, and construction industry. With BIM, project teams can collaborate in a shared cloud-based environment. BIM allows teams to create a dynamic 3D model of all the data associated with the project, capturing all physical and functional characteristics and relationships for buildings and infrastructure. Everyone on the team can access all essential data in real time to collaborate more easily, to use simulation and analysis, and convey design intent to improve designs, quality, and client satisfaction. And with today's critical need for sustainable construction practices and eco-friendly structures, teams can efficiently explore a wide range of options and develop innovative strategies to deliver comfort, performance, and energy savings. BIM enables close collaboration across design and construction teams, which can help reduce errors and rework and help teams achieve improved timelines, cost savings, and better project outcomes. Innovators like you are shaping new possibilities, moving ideas and designs from 2D to 3D and into the cloud, collaborating smarter to create solutions that the world needs today and tomorrow. And that is the power of BIM.
Right. So this gives us a little bit of information on what BIM is all about. Now, we're going to talk about the elements of BIM. Now we've understood the purpose of BIM, the implementation of BIM, the benefits of BIM. Now, these are the elements of BIM. We have the information, the model, we have the process, the people, and the technology. Now, on the information, we have two basic types of information as regards to BIM. We have the model and the documents. The model are the digital data of design, either objects, building, road, equipment that we are working on, while the documents are the digital version of paper drawing, prints, image, and video needed for that particular project. Now, the process also is what we're talking about. Now, it is not just about getting the information or getting the data needed, but also what process are we using to implement that collaboration between all industry stakeholders on the usage of BIM or in BIM implementation. And that is the process. Which process are we using to do that? We're also considering the people that are involved. These are the most important aspects of elements of BIM, because they are the ones that will effectively manage the implementation of BIM in any building infrastructure construction project. Now, the technology is basically where we're going to spend more time to understand. The last presenter actually covered a lot on this area, the Ds of BIM. Covers the area of 4Ds, the 5Ds, and the 6Ds. So I'm not going to spend much time on this area as he has actually done justice to it. So on the 7D that also talk about the as-built, we have the as-built project being able to be implemented on the BIM utilization. So let's just go to the BIM tools and its integration. So these are the tools needed for BIM application. We call them the BIM weapon of choice. These tools are covered in every aspect of design, in every aspect of the process involved in the project. We have the briefing, we have the design, the analysis, the plan, the manage, review, cost, and facility manage. These are the softwares. Many of these softwares many of us have idea of them, many don't know. You may know one or two on this slide. I don't know all of them, but these are softwares that covers the implementation of BIM. So starting from the area of the plan, starting from the area of briefing, the design, the analysis, the plan, they all have softwares that helps in BIM implementation. Based on research, we discovered that Autodesk Revit has been the most popular software used in BIM implementation. It has about 31% usage in BIM implementation. And being able to achieve this implementation means that all the project participants need to mutually agree on a particular version they are going to be using, so that there will be a collaboration between the softwares they are using. There will be a seamless collaboration between the softwares they are using, where they are, in this case, like it is part of the challenge or the consideration that the last presenter put out, that when stakeholders are working on a particular project, they need to work together on a particular version, being able so that they can be able to translate and put together what they are doing, be able to collaborate and being able to collaborate and work together on a particular software version. These are the Autodesk solution for BIM, starting from the conceptualization, the schematic design, the design development, and the documentation. We have softwares, the aspect of the sketch conceptualization. We have softwares that helps us to design logic that drives the behavior of design model. We have softwares that helps us to capture the existing condition and convert to BIM. These are all softwares operation. We have software that helps us on the schematic design to create intelligent 3D model. And also the design development, we have also softwares that helps us to do that. So I think most of the consideration the last presenter mentioned as regards to where we are in Africa, as how the facilities are not adequate to be utilizing BIM, is on being able to identify these tools and know how they can be applied in the BIM implementation. We have the Autodesk solution for BIM from the conceptualization. We have the Autodesk format. We have on the schematic design, we have the Autodesk Recap Pro. We have AutoCAD, which almost every one of us maybe know about. We have the Insights. We have the 3ds Max, and we have the Navisworks. These are different areas, are different BIM implementation areas, the softwares that helps you to implement this amazing workflow. On the format, we have the format to be able to capture a conceptualization where you'll be able to connect design concept to BIM without modeling. So we are not modeling with a high facility. You can see the difference between when you are modeling with Revit and when you are modeling with Format. Format gives that concept of what you are trying to build, a kind of conceptualization of what you have in mind, while the Revit gives all the full details. So the Format helps us to do work on the conceptualization of our design before moving over to Revit. While we have the Insight. The Insight is an analysis tool that provides information about the building projected energy use and the energy costs associated with meeting that demand. So it helps us to optimize building performance early in the design process. Helps us to use the leading simulation engine for determining the cooling, the heating, and the LED light effects of our structures. We have then the Navisworks Manage. Navisworks Manage helps us to fully get information about all the projects that we are working on, be able to control and manage the project outcome. So the Navisworks is one of the flagship of BIM solution. Is one of the flagship of BIM solution. It offers the AEC collection, that design consideration to holistically review the design that are collaborating from the architectural, from the mechanical, from the structural, bringing them all together and to be able to run a analysis of what is actually happening in the facility before the construction. Because when you're able to know how each design process is affecting the other, you'll be able to understand, can make corrections before the construction to avoid bringing it down, correcting. So the Navisworks Manage helps us to anticipate and help reduce potential clash and interference problem before construction. Then we have the Autodesk BIM 360. The Autodesk BIM 360 helps us in documentation management to accelerate projects schedules with multidisciplinary collaboration. also be able to access project data anytime, anywhere. So it works on the cloud where your every stakeholder can access documents, not just the design, but can also access documents of. I mentioned the information that we actually transmit through the BIM. We have the model, we have the document. The Autodesk BIM 360 help us to access this information seamlessly from the cloud. Now, on the aspect of the G7, we talked about the as-built projects. We have a scan to BIM, where we have currently a lot of projects or a lot of facilities. We have a lot of infrastructures that have been probably 20, 50 years. And there is no longer the soft copy information of that building. Now, the scan to BIM helps us to get information of that building by using a scanner, register the point cloud, send it to the Reka Pro. Before we send it to the Revit, Autodesk Revit for the modeling and the analysis. So the process is this: moving from the scanner then to the Reka Pro, extracting the point cloud and sending the point cloud to Revit architecture or Revit structure or Revit MEP. So the benefits of BIM, we've registered that about 72% has been achieved using in BIM implementation for greater cost predictability, 85% improved scheduled, 85% few error because we are using BIM, and 95% and 92% in optimized design. For better understanding also, in collaboration between all stakeholders, we've identified that using BIM or BIM implementation has helped us to register about 98% in collaboration between all the building or project stakeholders. Now, developing local capacity for BIM adoption. How do we develop that? All is by creating a BIM conscious engineers, people that know what BIM is all about, the benefits of BIM, the importance of BIM, and how BIM can help in building a sustainable infrastructure, having the government involved, because it is not just about the engineers knowing about BIM, but also we discovered that most implementation of technology or most implementation of engineering factors in different countries, it all drive from the government. Now, BIM consciousness is one thing that is very important, like what we are doing now. After this program, many of us will have that idea of BIM, know what BIM is all about and the best uses of it. And also for every company to be able to implement BIM, it is always very important that they bring in their staffs and make sure their staff understand the benefits, the process, and the best way to implement this model. The area of getting more information about implementation, you can get this information using the Autodesk Design Academy through the Autodesk Knowledge Network, Autodesk University. The COSTECH has built a lot of partnership with Autodesk, with universities, where we go to educate young students in the university on the usage of these softwares and this implementation, because these are emerging technologies. These students, most universities don't talk about BIM. They don't even know much about BIM, but creating that awareness helps in adopting BIM in our in the country or in our local operation. Also, we have our annually we have the COSTECH Annual Smart City Conference, webinars and workshops. We currently have one that is ongoing. We just finished the Scan to BIM program, where we practically utilized the scanner to produce an as-built project of a particular facility. So we can also access information about BIM from the CAD Learning, the Autodesk Training Center, the Autodesk Certification Center. So we have a poll that we want to run a poll now. I think the pool will be run now. So probably it's going to be dropped on it's going to be dropped on the chat, the link. Mr. Olamide, are you there? So in the absence of that, I think that is where we'll stop the presentation. Thank you so much. If you have any question, you can go ahead and ask the question. Hello?
Yeah, we are here, but
okay, I think the coordinator is having issue.
Yes, yes. So we're just waiting for him to get back on. Just give us some minutes. Thank you.
So if you have question.
Hello.
Welcome.
Good afternoon. My name is Professor John Ame from the Department of Building.
You are welcome, sir. Kindly go ahead, sir.
Yes, I am highly delighted at the presentation today, and I must applaud all the presenters, the initiator of the program, the seminar, the dean of the faculty, Professor Odupe Omiri, Professor Adebamawo, Architect Kulaja, and every one of you that presented. Yes, this issue of BIM is a very crucial thing that we need to really discuss, and I'm happy that this discussion is coming up now. Now, since BIM is not really a software, that means there is need for another software that probably have BIM incorporated that one can implement in schools, at least to teach students so that they can be familiar with all that is required about BIM and how to collaborate with other professionals digitally. You know, I also want to say something about what we have tried to do in the Department of Building over time. Like last year, by God's grace, we were able to get an educational software from a California-based project management company on a software that has been incorporated, which is a Procore, and somehow they were able to train some of the staff, in the use of the Procore so that we can equally also train the students. And I think that the challenge that we are having, just like Dr. Shotumbo mentioned, is really in the training aspect, because it's because most of us that are teaching today in the university, we are old school when it comes to the use of all these software packages, especially especially this BIM and all those things. And even in the training too, when we started the training, many of us could not even stay true to the end because of several commitment and challenges and things like that. And another thing again is the cost of this software is actually very expensive. If not that we got a free license, to get that software alone is over $200,000. So how many schools now with the way that schools are being facilities are being managed in the school now, how many schools can actually afford $2,000 for only a software to train students. So it's a big thing, and most of the research we are doing now on BIM in most universities is actually on adoption and awareness. They are not even really serious research, like one of the presenters mentioned. They are not serious research in BIM.
Yes.
So really, I
Yes.
appreciate all the presenters and what you have shared. I just pray that we'll take it beyond just this seminar to the classroom so that the students can benefit and maybe have competitive advantage over their peers in other schools and also beyond the shores of this country. Thank you so much for your presentation. I really appreciate all of you.
Thank you, sir. Thank you, Prof. We appreciate your comment.
Much for this. I think it covers a lot on the area that we are also involved. Now, Coastal Computers Limited has been building a partnership with universities in Nigeria. I think one of the problems we have currently now is the ASU strike. We've built partnership with Uniloring, First Technical University. Last week we did that with Kwara State University. So what we are doing is some of these softwares are actually free for students, where they can get access hand-on on it and be able to be trained on the usage of the software. So if maybe it's something that you can reach out to us, then we can talk further on it and also see how we can translate this to other schools in Nigeria. Thank you so much for that notation.
Thank you, Mr. Cyril. We appreciate that. Architect Okulaja, please, can you take?
Okay, thank you so much for this great presentation. At this time, I want us to put on our videos so that we can take a group video, a group photograph, if it is possible. Everybody that is interested in getting a certificate of participation for this event is free to contact me. I'll put our email on the chat group so that you can get your certificate of participation. It will be signed by my good self, the Dean of Faculty of Environmental Sciences, and also the speakers at this event. So I'm still waiting for everyone to put on that video so we can see their faces. Thank you so much.
Hello?
Ogunade Oluwapelumi, we are waiting for you. Isaka Odewale, Mr. Wellington, Eagle Glass, Oluwabus Dolami, please put on your video. So I'm going to take it in the next few minutes. And of course, this event is recorded, so we can all have access to it. Once it is posted, I will send an email through the link that you used to register. I want to thank everybody that has been on this call for participating, and particularly for us to know that we are all in this together. We need to get the knowledge and also the experience to have a change in the country, and also for us to also adhere to what we call the Sustainable Development Goals. And everybody that is interested also is entitled to a United Nations Sustainable Development Goals calendar. So you just email me with the subject G+BIM, and we will see how we can get it to you. So the floor is open for us to share the experiences and understanding of what we have all learned today. So at this point, you are free to speak through the microphone. You can unmute yourself and speak one at a time, please, so that we can all hear and understand what you're trying to say. Thank you very much. So we'll just do this for the next 2 minutes. Yes, sir.
Yeah, there is a question, or maybe there are questions
the
which I
question.
think we should add.
I'm not seeing that question yet. Can you read out the question, sir?
Well, there is a question from Ujiku to Amina. She's asking the question that now that BIM is very useful, how come there is still resistance to its implementation, despite all the benefits, especially in Nigeria?
I think, first of all, let's throw that to Costech, Cyril, because they are the holders of the portmanteau, of the software suite. And then we can also hear from Dr. Shotubo on that, and I'll also give my comments on that. So over to you, Cyril. Cyril, if you're available, over to you.
Sorry, I was having some network challenge. Can you repeat yourself? What you said?
I can hear you now.
Repeat the question. Can you repeat the question?
Despite the benefits of BIM, why do we still have resistance to its implementation in Nigeria?
Okay, I think it's not just about BIM. Technology embracement in Africa is one big challenge that that cuts across different industry. It is not just about BIM. Now, there are I think the presenter before me have actually touched a lot of areas as regards to that. There are facilities needed for such implementation. There are facilities needed for such implementation, ranging from the kind of system you are using. Let's bring it personal. Ranging from the kind of system you're using, the facilities that we have in Nigeria, we have a whole lot of internet problem. Now, most of these tools, for you to be able to work real time, you have to be online, working through cloud. Now, how do you achieve that when there is issue with internet? How do you also achieve that when you have issue as regards to power outage? We have power problem in Nigeria. So these are actually problems that we are actually facing as regards to the implementation of BIM in Africa. So it is what actually affects a lot of people, stakeholders that want to go into that. They are considering, how do I go into this, owing to the fact that there are some limitations that we have in the facilities of implementation. So these are actually the problem that we have in implementing BIM. But it still doesn't stop the usage of BIM. BIM on its own is an amazing process that helps us to achieve our desired outcome. Now, what we can do here is to, with the advent in technology, because technology is still growing, we're talking about 5G. Probably 5G is going to give us the kind of internet that we want, nobody knows. But with the advent in technology, when we keep embracing technology, the more we embrace it, like the last person asked questions about the young people getting to know about the usage of this BIM. Yes, when they get to know about this, it will help them to accept it more readily than the people that already know about it now and they are in the industry, and they will not have the time to go about the learning the software is needed for that. So the way forward here is making sure that the young people in the university, builders, understand this software, understand how to use it, understand the workflow, and also reach out to government, know that government policies affect industry operation. So these are the problems that we're having in BIM implementation. It's a kind of a problem that we have in all technology embracement in Africa. It's not just BIM. So if we're able to put this, in order, we'll be able to utilize and implement BIM adequately in Nigeria and other African countries.
Thank you very much. Mr. Shotubo.
Can I quickly add to what you just said? My name is Femi. I'm from Costech equally. To add to what you just said now, that is the sense of what creating more awareness within the students. Because if a student can be able to adopt technology, if they find themselves in any workplace, they can change the narratives. because that is the tools they know how to use to implement their project. So it will force them to change their narrative, like what Dr. Sotuba was said during his presentation, that the Nigerian, the people here are stubborn not to be able to adopt technology because of the way they want to cut corners. So all we need to do is the awareness already been created, people knows about it. The policies also, if possible, our professional bodies like NIOB, NIA, NSC, can especially bill, probably through the legislative council, to especially bid and make it one of the priority of implementation bill in Nigeria, the way UK go about their own, by forcing the industry to make sure that they are on level 2 of BIM implementation. If that one can be achieved, it's going to help a lot. But narrative will change if students can quickly be able to understand why they're in university. Because the moment they leave university, they are the workforce and they can make a lot of change. This is what I know how to use. Then they will make it sure that that implementation was being fed in their office. That's one of the things we can do. So we from COSTECH, we already started that processes by making sure that we engage students, because they are the one take over technology over time. And through them alone, they can drive BIM implementation across board. Thank you.
Thank you so much. So, Dr.
Okay,
Sotuba.
just to reiterate what has been said, I think we've all said it all. The two speakers said it all. Once we still have issues with infrastructure, BIM will struggle, because BIM is infrastructure as in information, communication and technology, co-infrastructural dependency. It depends on it. So if we are still having internet failure and so on and so forth, we will still be having issues implementing BIM. And also cultural issues. I think Mr. Adesina mentioned that as well. We are so used to a certain manner of work, and now we want a total shift. And Professor Ame also said something, that some of us are old school. So this new technology requires a different shift in the way we do things. And so we find it difficult. Somebody who is still trying to find a means of surviving in the industry, you are not telling him to, bring up BIM, invest in it, and then apply it. The person will say first, survivor first, before this. And of course, corruption. For now, we are still battling with it. BIM will not allow corruption. If you say, oh, you are bringing a 10 square meter door, that's what you must bring. In fact, that is what is already in the design. That is what everybody is seeing. That is what you must bring. If you are saying you are bringing 20 tons of sharp sand, that is what you must bring. And it must be up to it, because if not, it will affect the next supply. So, and the present system, people thrive through corruption. They even people make, they supplement their gains through corruption and several other things. And also government not bringing up the platform, not imposing or enforcing the platform. We saw in that presentation, UK government have to impose that by 2016. Everybody, if you must work for us, if you must deliver a project for us, you must be on this level. So the professionals have no choice than to be on that level. So if we do not have all these things in place, then to implement it will still be a problem. Thank you.
Thank you so much. I think just to...
Yeah. Can I make a comment?
Hello? Okay, go ahead, Dr. Bello. You want to say something?
I would like to make a disruptive statement. And that qualification of using the word disruptive is to conjure from all the speakers and contributors what they have said on BIM. Are we saying that BIM is not being implemented in Nigeria at all? Or we are saying that the level at which we are is low? Going by the definition of BIM, by understanding that it is not just software, but the process of managing information, which of course could be implemented in a concept of a software, as Professor Ahmed also mentioned. Now, as that question, portends for us to think as if we are a right statement to make that we are not implementing BIM in Nigeria, or we are to say that the level at which we are is low. I call it disruptive. It has to do with our understanding of the concept BIM. Thank you.
Yes, if you follow well the lecture, there has never been a point where any one of us said Nigeria is not adopting. We are adopting. There are projects that are being executed with BIM. Even Architect Ogulaja posted some 12 projects or 14 that have been executed with BIM. But the level of adoption is low. That's what we are saying. Compared to other nations with 80%, 79%, 73% implementation, not just awareness now, implementation. So, and of course, I also said that even those that are applying it in Nigeria are the top contractors with top clients. So it is yet to trickle down to the ordinary clients. That's what we are saying. And until it gets to that level, it won't attain that high percentage that we expect it to be. Thank you, sir.
Okay, thank you so much for that. Just to comment on everything that has been said, mine not being the last comment, everybody is still free to comment. I think it's a challenge to the students and also to the university community. BIM is not strange, and at least I know that everybody in this seminar understands the concept of what BIM is. It's basic information that is layered, and now it becomes complex. What I would throw to the university community, and particularly to the students, is for them to start developing their own local software for BIM. It doesn't need to be a very, very complex thing, but you must have the courage to start. When you start something, you can make it open source, and people will start to develop it. That is how the nations of this world began to develop. That is what development is called. That is how you get innovation. You get innovation through co-creation. Somebody that has a fantastic idea can add to your own idea. But if you don't make it open source, we'll always be going to Europe to try and get software, and they will charge us an arm and a leg, or even a whole person to use it. So let us start looking at it. We have very brilliant students in our university there, University of Lagos, who can write code and write software. And once they know that this software can be applied in Africa, it becomes a source of revenue to them that they can build upon. And you can use BIM for so many things. You can use BIM to even design a car. You can use it for product design. You can use it for so many analytics. So it is up to us to say, where do we want to start? Do we want to take what is freely available to us and adapt it to our local situation? Or do we want to use our own software and go 101 and say, this is how to go? But again, we want to also look at the people who are already on the field, like Costech. It is not difficult for us to start our own BIM lab. We can have it in a conceptual way, but it is not even hard for us to have at least 2 or 3 computers, or even 5 computers available to the Faculty of Environmental Sciences, and let our students have access to it. It is not difficult. All these things are a matter of putting your heart towards it and getting the people who can fund it and people who can use it, and then let's get innovation and productivity from it. So I think we should just open our minds to the challenge and see what is available to us for the future. So as we are rounding up on this event, I want us to really look inwards and say, with this seminar that you have heard now under GLASS and BIM, what are the solutions that you can bring individually? What can you present to your own country, to your own community, to improve what we have been talking about? We're talking about electricity. We're talking about so many other things. What are the innovations that you can bring to bear to help resolve this problem? Each and every one of us here are problem solvers, and we have the capacity to do so. The simple thing that we have in our hands, which is the mobile phone, is even more advanced than the computer that they used to send the first astronauts to the moon. So let us look at it, look inwards and see what we can do. So the floor is still open for anybody who wants to say something. We have a few minutes till we give our closing up facility. And then there's a poll that has just come up. Please fill that poll and let us see what we can get from this event and make it very successful. So the floor is open to everyone. Thank you.
Yeah, thank you so much, sir. You made mention of how to localize the tools that we can use for BIM in our country. And you mentioned that we have somebody that can develop an application. Yes, there's a software that comes with a BIM solution called Dynamo. The Dynamo is effective tools that they can use to create their own version of workflow, and they add it to any of those Autodesk products. Apart from that too, we will discuss with you after this to see how best we can implement or probably come to you like and create an environment where the student can learn more on the apps, like Cloud Appa, like Dynamo, that they can use to add like add-ons to any of those BIM softwares. The more we do it locally, the better we are, which is rightly said. Because if we don't do it ourselves, we keep on depending on foreign partners. We are not ready to develop our own way of doing things. Because once we're able to develop an app that can help us solve our immediate challenges, then we will be able to adopt it easily and make it open source for people to use. So we work with you and see how best we can assist in making our students to be more productive in that aspect. Thank you for bringing that to bear. Thanks.
Okay, before we call it a day, I think let me just appreciate the organizer of this event. Knowledge is power. We've learned so much today on BIM, but just note that BIM is vast. The application of BIM is vast. BIM is just a process, and we now tie it to glass. So we can still narrow it down to other specialized discipline, architecture, construction. So what I'm trying to say this morning is, let's keep the campaign going. So events like this should be frequent to create more awareness. Awareness is the key. Just like the COVID-19 thing, why it went viral is because of the awareness. The awareness was massive. Other diseases kill more than COVID-19, but just because of the way the media presented this particular deadly disease to the entire globe, that's why it went viral. So let's be an ambassador of change to take this to the larger society. Let people know more on this BIM process. Let's talk to schools. Let's come up with webinar, frequent webinar on topics that are related to BIM. And in the nearest future, you'll see that people will be buying into this technology. Let's not just look at the difficulty in the adoption. Let's also look at the positive part of it, that we can work seamlessly if this technology is being adopted. Thank you.
Okay, thank you so much, everyone. So if I may, can I call on Professor Adebamawo to please give us his remarks on the discussion, if he's available?
Oh, yes, I'm available. Yeah. How are you? Well, I want to thank all the resource personnel, all our speakers, and particularly to the organizers of this virtual meeting, or should I say seminar now. I think we've had a very good, robust time of interaction and discussion on BIM, and particularly our guest speaker, Stephanie, and our own Dr. Shutumbo, and all those who also presented. I don't remember all the names. And contribution from Professor Ahmed, Dr. Bello. And we could see that there is still more for us to be able to do when it comes, to BIM. Yeah, to some extent, it's good that for those of us who are also in top practice, we have not conversant with BIM, especially we are practicing here in Lagos, Nigeria. I can confidently say that you have not started, okay? Because even the level, as Dr. Shutumbo breaks the whole thing down from 0 level to 1 to 2 and to 3, at that level 3, before you know it, there are other softwares that will come, because things are evolving, and they are not static, they are dynamic, especially when it comes to all these digital operations. So it's not even sufficient that you are aware and that you are already utilizing the tools, but that you keep your feet on you are really on ground and improving, as new softwares and improvements in technology are coming up, training upon training. And that's why you find most of professional firms too sending out, their architects, engineers, builders, QS, for further training. So I want to appreciate everyone who had put this together, because this really is very impactful and it's enlightening that from time to time, we can also see the role that this is playing along with our own main goal, which has to do with Glass Unlimited, okay? And we cannot actually utilize the potentials of glass if not through, BIM. We cannot work, utilize, maximize, the potentials of glass, all the possibilities that glass will give you, and we have had all that in terms of the sun shading, requirements, and the angle at which we are operating this, in terms of solar radiation, ventilation, and these are rules that we know fenestrations, glass will bring to bear. But for you to be able to effectively design to ensure that that rule is, properly played, you need to understand the principles, the science, behind it. And the tools that you will also require in that implementation is exactly what, BIM does for us. So that is the order of the day. That's the direction to go. And I'm glad too that those of us who are in academia that also involved in this, definitely is clear from me that even in our own curriculum in schools, because all these tools, our students need to be very familiar with that. And I'm glad that even if we don't step up the game to ensure that our curriculum responds to those demands in the industry and the trend that is going on now, these students are so smart that they are not even left behind. On their own too, you'll be surprised that they are ahead, of the lecturers. So we have no choice but to utilize the opportunity of curriculum review to look into, our various courses and the course content, and also ensure that we have been able to incorporate that effectively. I've heard what HOD Building also said, which is in that positive direction. And many years ago, or a few years ago, too, in architecture, all that really has been done. But my final comment is just that, yes, we're doing all that, but we should please continue, because these all things keeps evolving. And technology, in fact, with what has been presented today, before you know it, in a few months' time too, if you are not updated, you find out that the world has left you behind, because many, many other things are coming up, new things, innovations, are coming up to get things done better, to get things done quicker, to be more efficient in terms of energy, in terms of time, in terms of cost. So all these things are really evolving. Unlike those days that when you talk about glass, then you want to run away from designing and having cutting walling and putting it all glass. As a matter of fact, if you try it in the 80s or even early 90s, your design is knocked down. That no, it's not effective, it's not efficient, solar radiation, that and that and that. In the tropics, how will you do this? But now it is, as if any lecturer says that now, you just laugh that this one is behind, is old school, in the sense that you can use glass that effectively now, okay? And all these challenges associated with the use of glass in terms of solar radiation and the rest of that, that, glass had gone beyond that. Technology has given us ways of improving the utilization of glass. So please, let me just stop there. I think this really is very good. And I want to encourage us that from time to time, we still need to do more of this. It shouldn't just be a one-off thing, but that as we have more of these too, we enlighten ourselves further, we'll be able to also see new things, innovation that are coming up, and we are just on top of the game. And we'll also be able to collaborate with our international, colleagues all over the world in ensuring and putting into use, BIM. Thank you very much. I appreciate you all. God bless.
Thank you so much, Professor. We really appreciate your attendance of this event. And we're just halfway into our celebration for the year. And I know that we're going from strength to strength. Thank you so much. I want to thank everybody. Apologies for our current dean. She's unavoidably absent. She had to attend to something else, but I'm not sure whether she's online now. I don't see her name, but she sends her regards. I want to ask our speakers to say a few words in closing, and also Dr. Bello to give us the closing remarks on behalf of our dean. Thank you so much. So we have the speakers first, and then we have Dr. Bello to give us a roundup and close the event. Thank you so much.
Thank you, Architect Okulaja. I want to appreciate you and everybody, Professor Adebamowo, Professor Mary, for giving me the opportunity to speak today. It's a great honor and privilege. as I've said, BIM is the way to go. And we just have to keep pushing until we get there. Process something that before you know it, the knowledge you have now becomes outdated. So we just have to keep pushing at it. It's a pleasure to be in our midst today. Thank you so much. God bless us all.
Okay, thank you so much. It's a great privilege for me to be part of this program. I really appreciate the organizers of this event, and we look forward to do more. It's very important. It's not just about the seminar, it's also implementing what we have actually learned. We have actually discussed a lot of things here today, and one thing that stands out, if you look at it, is that we need to look at industry-academia relationship, industry-academia partnership, where we bring to the notice of young students in the university of what is actually happening in this fourth industrial revolution, what is happening in this emerging technology. So it's a great opportunity to be part of this event, and we look forward to collaborating more on this awareness and also in the training aspect. Thank you so much.
I wouldn't know if Stephanie is online. Architect Kulaja.
Yes, sir.
I wouldn't know if Stephanie is online.
No, she's not online. She had to take her leave. She had an event and a meeting that she had to go to. So I think on this note, we are right on time. We are on 1:01. We scheduled for 1 o'clock. So I'd like to appreciate everyone for tuning in, and keep your calendars open, because we're going to send you more information on more events that we'll be having. Thank you so much for being our guest today. And please
and on behalf of the Dean of the Faculty of Environmental Sciences,
information about what you learned today. And you can always send an email to us. I've put the emails on the chat box, yearofglass2022@gmail.com, and also Alkaline Beehive Design Foundation@gmail.com. Thank you so much. With this, we bring the event to a close. Thank you, and have a great rest of the day.
Thank you too. Thank you. Thank you, sir. Thank you, Mark.
Bye.
God bless you. Bye.
Bye-bye.